Hi everyone, welcome to section 6.1. And in this section 6.1 video series, we're going to be learning or reviewing power series. Okay, so we're going to go over some of the basics of power series so that we can apply it to solving differential equations is what we will learn in future material. But let's go ahead and look at the learning objectives for this review portion. Okay, so we're going to reintroduce the definition of power series. We're going to reintroduce ratio tests, interval and radius of convergence. We're going to refamiliarize ourselves with basic Taylor and Maclaurin series. We're going to perform arithmetic on power series, index shifting, peeling off, and then lastly, we're going to solve a differential equation using a power series. Okay, so let's go ahead and introduce or reintroduce ourselves a bit with power series. So, as we have seen throughout the course, higher order differential equations with variable coefficients, meaning like x, some type of function of x, cannot be solved with elementary procedures. Okay, so a usual course of action for equations of this sort is to assume a solution is in the form of an infinite series. So when we talk about infinite series, we talk about something like, you know, or not x to the n, sorry, something like a to the n or a sub n. That's what we talk about for an infinite series. So in section 6.2, which we'll learn next, we consider second order differential equations, meaning like second derivative, with variable coefficients that possess solutions in the form of a power series. Okay, and what is a power series? It's an infinite series as well, but this is where we have the an x to the n. Power series because we now have that variable x. Okay, so let's review the basic concepts of power series from your calculus course that you should have learned. Okay, so a little bit of a review, a little bit of uh, reintroduction. So here's power series, all right? Here's a definition. Recall from calculus that a power series is anything of the form like this. We have an infinite series. We have a constant c sub n, so these are like our constants. And we have x minus a raised to the n. And this a right here, if you could recall, is the center of our power series. Okay, so that's the general term. And then the c naught plus c1 times x minus 1 plus c2 times x minus a squared. That is just these terms expanded out. Okay, so some notes about the power series. So just a little refresher on what the summation is and what index are, things like that. So that n equals 0 is called the starting index. This n equals 0 right there. And we use n generally, but we can also use whatever variable we want, n, j, k, etc. Just maybe not x or y, so we don't get confused. And sometimes we won't always start at 0. We might start at 1 or 2, just whatever the problem depends on. And so A here in the general definition is what's called the center. And so when we do these power series, we call the series a power series centered at A. And so here in this introduction differentials course, we'll usually let A equal 0 in these problems. So the series is just x to the n. Okay, so think about it like you know, x minus 0 raised to the n. But we don't need to write minus 0 because it's just going to be x anyway. So yeah, we typically let a equal 0, so that just becomes Cn x to the n. Okay, so the center is 0. Okay, so let's look at a couple quick examples of just identifying what the center is. So here's a series right here, starting at n equals 0, x plus 1 to the n. So since we have x plus 1 in here, remember the general makeup is like power series Cn x minus a to the n. But here we have plus 1. So what this means is that this is, I could rewrite it even, maybe that's a little better. I could rewrite it as x minus negative 1 to the n. So what this means is that it is a power series centered at x equals negative 1. Okay, so let's look at this next one. We can rewrite this just to make it easier to see what the center would be, like 2 to the n, and then x minus 0 to the n. So that just means 0 is a center. So power series centered at x equals 0. Okay, so that's just a little bit more recap of power series, just a bit of a introduction, reintroduction. We're going to get going on some more topics later on in this series of videos, but just want to reintroduce it, get reacclimated, and start taking it up from there. But that's it for this video. Thank you for watching, and I'll see you in the next one. Take care.